All right, welcome to a very rare lunchtime video. Um, uh, I used to do these very frequently because I was studying for my first attempt of the JNCIE using all public resources, doing all my study in public. So um, I used to do lunchtime videos every day for that. Update on the retake, I went ahead and purchased the official study materials. So I am planning to retake. The labs aren't available for a month, like probably like a few weeks or like a month later than I thought they were. So I might have to push my retake back, but it's not going to be that big of a deal to do that because I I'm actually a lot more likely to pass now that I have better study materials. But this video here is going to be working towards the solution design guide by Cisco for LAN and wireless LAN architecture. I'm hoping to get all the way through
Wild
that
networking.
and then move on to something else for the wild networking series. So let's waste no time and uh, get reading on that. So this is Cisco DNA Spaces. DNA stands for Digital Network Architecture. Cisco DNA Spaces provides organizations with rich location-based wireless services, including location analytics, business insights, customer engagement toolkits, asset management, enterprise integrations, and location data APIs. This cloud-based platform, which is compatible across Cisco AeroNet, Cisco Catalyst, and Cisco Meraki wireless APs, lets your enterprise see activity at its properties, act on these insights, and extend platform capabilities via integrations and partner applications. With Cisco DNA Spaces, you gain the following benefits. Simplification, a single unified platform for accessing location products and apps, and for normalizing data to create meaningful insights. Cloud first, scalable, a cloud first software as a service SaaS approach that enables presence and location connection to the cloud across the entire installed base. Standardization, compatibility and interoperability across all Cisco Wireless, Cisco AeroNet, Cisco Catalyst, and Cisco Meraki. Support 24/7 monitoring and service level agreements, SLAs, for end-to-end reliability. Low touch. No need to upgrade your underlying network infrastructure to activate service. Cisco DNA Spaces takes the wireless network beyond connectivity to drive digitization in 3 easy steps: see, act, and extend. So here's a diagram. I'm assuming this will explain the 3 steps: see, act, and extend, but we'll see if that is the case, and then we'll act accordingly, and then we'll extend on to the next section of this guide. Okay, so we do have it. So here's the C. I guess I can't tell what belongs to the C. It's just not clear, especially since these toolkits seem to belong to both. So maybe C. I guess this makes sense because the location, insights, and the unified dashboard, those more are things that you see. Actions, yep, toolkits kind of belong to both. Yep, API, you can do get, pull, get post requests, update, patch, delete to, so those are actions. SLA and monitoring, take actions based on the stats of your network. Security and privacy, more actions. So yeah, we've got presence locators, we've got location processors, and then we've got extend. So you can extend this out to your partner apps. Um, yeah, so okay, that's enough of that Cisco DNA Spaces diagram. Now you can see what's happening at your properties. Act on this knowledge through digitization toolkits and extend platform capabilities by leveraging a partner app ecosystem. Cisco DNA Spaces provides support for all wireless deployment modes. Not recommended. An on-premises deployment of Cisco DNA Spaces is required for the following. Hyperlocation. To use the Cisco AeroNet 4800 series or 3700 series APs with a hyperlocation antenna, or to use FastPath on all APs on an on-premises server, it is required to receive FastPath UDP data on port 2003 from the access point and use it for location calculations. Integration with Cisco DNA Center or Prime infrastructure. To provide location data to Cisco DNA Center or Prime infrastructure, an on-premise server is currently required. Wireless design models. This guide describes the following design models and their recommended use. Centralized local mode design model, Cisco Flex Connect design model, Cisco SD Access wireless design model, Cisco Catalyst 9800 embedded on Catalyst 9100 series APs EWC design model. First design model, centralized local mode design model. A centralized design model, also known as a local mode design model, is recommended primarily for large site deployments. The benefits of a centralized design include IP address management, simplified configuration and troubleshooting, and roaming at scale. In a centralized design model, the WLAN controller and APs are both located within the same site. You can connect the WLAN controller to a data center services block, a separate services block off the campus core, or a LAN distribution layer. Wireless traffic between WLAN clients and the LAN is tunneled by using the control and provisioning of wireless APs, CAPWAP, protocol between the controller and the AP. This has the advantage of decoupling the subnet on which the wireless clients terminate from the AP, requiring the availability of the wireless client VLAN only at the controller, thus simplifying the deployment. So let's try to figure out where the controller is. Okay, so we've got Internet Edge guest anchor controllers. I think this is it, WLC. So, excuse me. Okay, I'm not quite sure what to make of this diagram here. I don't see how things are localized or the availability of the wireless client VLAN is only required at the controller. I don't see a controller. I guess WLC stands for controller. Let's take a look at the glossary and see what WLC stands for. I think it stands for wireless LAN controller, but let's take a look. It shows up quite a bit in this guide. Okay, yeah, wireless local area network controller. The L can stand for local area network or LAN. So the middle letter in the acronym is an acronym. Stands for an acronym. A centralized architecture uses the controller as a single point for managing layer 2 security and wireless network policies. It also enables services to be applied to wired and wireless traffic in a consistent, coordinated fashion. The local mode design model meets the following organization demands. Seamless mobility enables fast roaming across the campus so that users remain connected to their session even while walking between various floors or adjacent buildings with changing subnets. Ability to support rich media enhances robustness of voice with call admission control and multicast with Cisco video stream technology. Centralized policy enables intelligent inspection through the use of firewalls, as well as application inspection, network access control, policy enforcement, and accurate traffic classification. If any of the following are true at a site, you should consider deploying a controller locally at the site. The site has a data center, the site has a LAN distribution layer, the site has more than 100 access points, the site has a wide area network latency greater than 100 milliseconds round trip to a proposed shared controller. The recommended platforms for large centralized local mode designs are the Cisco Catalyst 9800-80 and 9800-40 WLAN controllers because of their scalability and feature support. For smaller sites, you can deploy the Cisco 9800L WLAN controller as a local controller within the site. The Cisco Catalyst 9800CL virtual form factor deployed within a private cloud is another alternative that includes the same feature set as the Cisco Catalyst 9800 series appliances. Cisco FlexConnect design model. Cisco FlexConnect is a wireless solution primarily for deployments that consist of small multiple remote sites, branches, connected into a central site. Cisco FlexConnect provides a highly cost-effective solution enabling organizations to configure and control remote site APs from the headquarters through the WAN without deploying a controller in each remote site. Cisco APs operating in Cisco FlexConnect mode can switch client data traffic out their local wired interface and can use 802.1q trunks in order to segment multiple WLANs. The trunks native VLAN is used for all CAP-WAP communication between the AP and the controller. This mode of operation is referred to as Cisco FlexConnect local switching and is the mode of operation described in this guide. Cisco FlexConnect can also tunnel traffic back to the centralized controller, which can be used for wireless guest access. You can use a shared controller pair or a dedicated controller pair in order to deploy Cisco FlexConnect. In a shared controller model, both local mode and Cisco FlexConnect configured APs share a common controller. A shared controller architecture requires that the WLAN controllers support both Cisco FlexConnect local switching and local mode. In this guide, the WLAN controllers that support both are the Cisco Catalyst 9800-80, 9800-40, 9800-L series appliances, and the Cisco Catalyst 9800-CL for private cloud wireless controllers. You may be able to use a shared deployment if you meet all of the following requirements. You have an existing local mode controller pair at the same site as your WAN aggregation. The controller pair has enough additional capacity to support the Cisco FlexConnect APs. The number of site tags with Cisco FlexConnect profiles required matches the capabilities of the controller pair. If you don't meet the requirements for a shared controller, you can deploy dedicated Cisco Catalyst 9800-80, 9800-40, or 9800-L series wireless controllers. The Cisco Catalyst 9800-CL virtual form factor deployed in either a private cloud or public cloud is an alternative to an appliance since wireless traffic is typically locally terminated in a Cisco FlexConnect deployment. The Cisco Catalyst 9800CL deployed within a public cloud only supports Cisco Flex Connect with local termination. The Cisco Catalyst 9800-CL deployed within a private cloud supports local termination as well as centralized termination of wireless traffic, although at a lower scale, up to 1.5 gigabits per second, than a dedicated controller appliance. For highest resiliency, deploy a pair of controllers in a HASSO configuration. Alternatively, you can deploy N+1 high availability in order to provide cross-connect resiliency if desired. With N+1 HA, APs are configured with a primary, secondary, and even a tertiary WLC wireless LAN controller as desired. If connectivity to the primary WLC fails, the CAPWAP tunnel goes down. The AP establishes connectivity to the secondary WLC, potentially deployed at a different regional geographic location. If all of the following are true at a site, you should consider deploying Cisco Flex Connect at the site. The site LAN is the single access layer switch or switch stack. The site has fewer than 50 APs. The site is one of many small remote sites connected to a central location. The site has a WAN latency less than 100 millisecond round trip to the shared controller. Cisco SD Access Wireless Design Model. Cisco SD Access Wireless is the fabric-enabled wireless solution that, unlike any alternative solution, fully integrates with a wired Cisco SD Access model. The primary benefit of Cisco SD Access Wireless is that organizations can have a common policy and unified experience across both wired and wireless. In this model, the Fabric WLCs communicate wireless client information to the Fabric control plane, and the Fabric APs encapsulate data into the VXLAN data path. Note, SD access wireless control plane traffic is passed to the WLC, while data plane traffic is passed directly into the Fabric. The distributed data plane allows the solution to scale more easily, avoids hairpinning of wireless traffic through the wireless controller, and retains the ability to easily stretch the layer 2 domain. Requirements for deploying Cisco SD Access Wireless. Cisco SD Access Wired Fabric deployment is required. APs with Fabric mode support directly connected to Cisco SD Access Fabric edge nodes. WLC with Fabric mode control plane support. 20 milliseconds or less latency between the Fabric APs and the Fabric WLC. Cisco SD Access Wireless Design Model. Cisco Catalyst 9800 embedded on Catalyst 9100 series access points, EWC. So embedded wireless controller, I think that stands for. Wireless design model. The Cisco EWC is a Wi-Fi solution using a Cisco Catalyst 9800 series wireless controller embedded into the Cisco Catalyst 9100 series APs. The Cisco EWC is an alternative to Cisco Flex Connect deployments for small wireless deployments, since a separate on-premise controller does not need to be deployed. The Cisco EWC platform provides the following benefits: high availability with active and standby controllers running simultaneously on two Cisco Catalyst 9100 series APs, configuration synchronization, not high availability SSO. And SSO is single something something. Let me see what SSO is. single sign-on. Uh, oh, sorry, stateful switchover. Software maintenance updates, SMUs providing hot patching of the controller, AP device packs and AP service packs supported like standalone controllers, Cisco DNA digital network architecture center support for plug and play, automation and assurance, including intelligent capture similar to other deployment models, enhanced radio frequency features such as flexible radio assignment (FRA) and Cisco Clean Air technology similar to other deployment models. Automatic configuration of wireless best practices from more than 10 years of experience with large and medium scale implementations. If the following are true, you should consider deploying the EWC at the site, single site or multi-site enterprise locations with up to 100 APs and 2,000 clients per side for Cisco Catalyst 9120AX or 9130AX series running EWC, embedded wireless controllers, or up to 50 access points and 1,000 clients per side for Cisco Catalyst 9115AX or 9117AX series running EWC. And let's verify EWC. I'm sure it does stand for embedded wireless controller, but we will see. Okay, so EWC was never defined. It was introduced as an acronym, but it was never defined. Um, I mean, that happens a lot in this kind of documentation. It's kind of one of my pet peeves. I have a write up on that on my blog, how it's kind of a pet peeve, but I'm sure it stands for embedded wireless controller. What else would it really stand for? Guest anchor is not required, currently not supported on the EWC. Layer 2 roaming only without mobility groups. Note, Cisco 802.11 AC Wave 2 APs can join a Cisco EWC network and service clients, but Cisco 802.11 AC Wave 2 APs cannot run the EWC function. See, and this is where, honestly, like, I'm not sure I'm going to continue to read design guides um, because RFCs, like, the design guide is basically just, if I think I can get more out of just reading the RFC, and this is all of the standards track RFCs. It's going to be a lot, but I mean, honestly, like, look, this is not even that much. I mean, this guide here is huge. It's a lot bigger. Okay, that might be all I have um, the energy for today. Over 20 minutes. I think that's enough. I wonder if I could do. No, I think that's going to be it. It's going to be a short video. I don't want to max myself out too much on this, especially since this really isn't clicking a lot with me. So one thing I might want to do, let's see here, Cisco Service Provider Design Guide. I might want to switch and read the design guide for service provider networks because this is those are the popular ones. So let's see. Uh, What's SAP? Well, I don't know what SAP is, but yeah, I don't see anything for service provider, which is interesting. Okay, so here's all of the service provider products and solutions. So that would be definitely something that might overlap with the JNCIESP. Yeah, so here's solutions. So yeah, I don't even know. Yeah, I mean, I've got the official materials now from Juniper, so just stick to that, and then in my spare time, just work on whatever for this series. All right, so that's going to be it for part 14 of this guide. Oops, and it looks like I lost my place. So let's try to find that quick. I think it was, yeah, okay. All right, so see you in the next video where I go over AP site TID considerations.